All right, this is AP BC Calculus. We are doing a BC only section. This is Unit 10, Section 14, finding Taylor and Maclaurin series for a function. So you are on your AP 100,000,000% going to have to use the memorized sine, cosine, and e to the x Maclaurin series to create new series by plugging in different values for x. Please, please, please practice this. So here are the three series that we're going to talk about, the Maclaurin series for sine, cosine, and e to the x, right? So please memorize these. You want to have them be an autonomic response. You want to know them without thinking. We're going to use these as the basis for the next several problems that we do that will escalate in difficulty over the course of this video. So we're going to write the first four non-zero terms and the general term for the Maclaurin series for f of x, where f of x is the sine of 3x. So I want you to recall, right? So we're going to recall that sine of x, right, is the sum from n is 0 to infinity of a -1 to the n, x to the 2n plus 1 over a 2n plus 1 factorial. But really what you need to remember from that is that it's the odd powers of x that starts with 1, right? And it's the factorial underneath the power, right? So these are the first four terms, dot, 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 and this is the general term, right? The -1 to the n, x to the 2n plus 1, all over 2n plus 1. So I need you to have that committed to your memory, right? I need you to be able to do that without looking it up. So now what we're going to do is we're going to use that, but instead of an x, it's a 3x. That's literally the entire game. Sine of 3x is going to be, anywhere I saw an x, it's a 3x now. That's the whole game. That's it. So 3x minus a 3x in parentheses to the third over a 3 factorial plus a 3x in parentheses to the fifth over a 5 factorial minus a 3x in parentheses to the seventh over a 7 factorial plus dot, 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 this -1 to the n, and instead of an x, it's a 3x. That's the entire game. That's all you have to know how to do this. Really, that's it. But if you don't have the series that you start with, the thing I wrote in red memorized, you're kind of stuck. There's not much you can do. So please, memorize the three series I told you to memorize. This is them. Make note cards. Practice them constantly. Have them very, very ready in your brain. All right, we're going to do the same thing with e to the x squared. So, as a reminder, recall that e to the x, right, was 1 plus x squared over 2 factorial plus x cubed over 3 factorial plus dot, 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 x to the n over n factorial. Well, the only difference is it's not an x, it's an x squared. So, anywhere I saw an x, it's an x squared now. That's the whole deal. So e to the x squared is a 1 plus, instead of an x, it's an x squared. Plus, instead of an x, it's an x squared squared over 2 factorial. Plus, instead of an x, it's an x squared cubed over 3 factorial. Plus, dot, 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 x squared to the n over n factorial. Now, you might see that they want that slightly simplified. They might prefer to see that as a 1 plus an x squared plus an x to the fourth over 2 factorial plus an x to the sixth over 3 factorial plus dot, 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 an x to the 2n over n factorial. That's great. It doesn't really matter. But that's the entire game. Did you memorize the Maclaurin series? Are you able to plug in a different value for it? All right, so we're going to write the first three non-zero terms and the general term for this Maclaurin series. So this has a max series that we memorized. And this is literally just a number being multiplied by that series, right? So the cosine of x would be 1 minus x squared over 2 factorial plus x to the fourth over 4 factorial plus, they said 3, that's all I need, dot, 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 a -1 to the n, x to the 2n over 2n factorial, right? That's it. Okay, so if I then take this and put that in front of that series, x squared times cosine of x should just be an x squared times this entire crazy mess that we just wrote. 1 minus x squared over 2 factorial plus x to the fourth over 4 factorial plus dot 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 negative 1 to the n x to the 2n over 2n factorial dot 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 forever. Well, when I multiply, I was only asked to write the first couple terms, right? So I'm going to get that this, I think they called it f of x, they did, that f of x is, when I multiply, I get x squared times 1 is an x squared times the x squared is an x to the 4th over 2 factorial, x squared times the x to the 4th is an x to the 6th over 4 factorial, plus dot 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 dot, this is going to be an x to the 2n plus 2, because that's what would happen if you added the exponents, all over that 2n factorial. That's it. Right? So again, if you know the building blocks, if you know these series that I really, really need you to memorize, this isn't going to be a super challenging proposition. But if you don't know them, it's really hard to construct these. It would take you forever. You would do it the horrible old school Taylor way of finding f prime of 0, f double, or f prime of 0, f double prime of 0, f triple prime of 0. It would be awful. You want to memorize the Maclaurin series for those functions. Okay, so same idea. You're going to write the first 3 non-zero terms of the Maclaurin series for f of x. So we can use e to the x equals 1 plus x squared over 2 factorial plus dot 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 x to the n over n factorial. But the trick is that it's a 2x. That means that e to the 2x has to be a 1 plus, instead of an x, it's a 2x. Plus, instead of an x, it's a 2x quantity squared, right? Because it was an x squared, so now it's a 2x squared plus dot 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 dot. This is a 2x to the n over an n factorial, right? Dot 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 dot. Okay, so now I know that that's what this red thing is, right? Well, now I realize, hey, they're just putting an x in front of it. So f of x is just an x times the thing I just wrote in red, right? So it's just an x multiplied by this series, which I can totally distribute in here. This is a 2x squared over 2 factorial plus 2x to the n over n factorial, and then look at that ellipsis. All right, so I distribute the x, and I get that my f of x is an x plus a 2x squared. And if you want to clean this up a little bit, you can. It doesn't really matter to me. You might see that somebody writes this as like a 2 to the n and an x to the n. It's up to you. There's a couple different ways to deal with this. Probably the most likely way that you'll see this dealt with is that someone will write this as a 2 to the second and an x to the second and a 2 to the n and an x to the n. So what's probably the easiest option, right, is to write this as a 2 to the second and an x to the third over 2 factorial, right? And then dot 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 dot, a 2 to the n and an x to the n plus 1, because there's an n on the x and also this first power over an n factorial. But there's different ways to write it, and they'd probably also be equally acceptable. But that's kind of the gist. If you so if you had left it as x plus 2x squared plus, let's say you'd even chosen to simplify. I mean, you could probably have just left this one as a 2x squared times an x over a 2 factorial, right? And you could have probably just left this as a 2x to the n times an x over an n factorial. That would be fine, right? It's not a big deal. The gist is that they care that you understand how to make the function. It's a lot less about the tedious math. All right, so let's do a tricky one. This is hard. We're going to write the first 4 non-zero terms of the Maclaurin series for f of x. So again, this you want to have memorized. You want your brain to say, oh, hey, e to the x, I know that you are a 1 plus an x squared over 2 factorial plus an x to the third over 3 factorial, blah, 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 blah. Notice they didn't ask me for the general term, just the first 4 non-zero. Here's why this is tricky. This is not a monomial. Not a monomial. When you multiply polynomials that have more than one term, you have to distribute, and that's going to be real hard considering that this has infinite terms. Right? This has infinite terms. So distributing this thing is going to be real hard. So f of x is going to be x plus 3 times, and then this red thing. Well, because I was only asked to find the first couple terms, right? I was asked to find, I think, the first 4 non-zero. I can distribute the first 4. The trick is that I don't know what's happening after that, right? So when I distribute, right, I'm going to start by distributing the x first, right? So when I distribute the x to these guys, I'm going to get x plus x squared plus an x cubed over 2, because that's what 2 factorial is, right? Plus an x to the 4th over 6. Cool. That guy's done. Then I'm going to distribute the 3, and I'm going to get the 3, and I'm going to get a 3, which I'm not going to line up with the x because it's not the same, plus a 3x because that does line up with the x, right? 3x. Plus, this will be a 3 halves, x squared, right? And then when I multiply by this guy, so that was the 3 halves, I'm going to get that this is a plus 3/6 x cubed. And it turns out I don't need this guy because they said the first 4 terms, right? They said the first 4 terms, and that would be the 5th one because I have a constant term and I have a linear term and a squared term and a cubed term. So now I'm still going to have to combine them, and it's not going to be the most fun thing in the world. But my f of x is going to be approximately, because it's not all of the terms, a 3, right? These guys sum to a 4x. This is 2 halves, right? So that would be a 5 halves x squared. This is 1 half, and this is also 1 half, right? So that's just going to be a single x cubed plus dot, 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 dot. And I could actually take away the approximate as long as I put the dot, 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 right? So those are my first 4 non-zero terms. You'll notice I wasn't asked for the general term because you're not going to be able to find the general term here in any meaningful way. Because of the x plus 3, you can't really distribute to infinite terms, so it's going to be very difficult, if not impossible, to find the nth term in a way that would make logical sense. So same idea, right? Again, your job is to have this series memorized, right? So you want to say, oh, hey, sin x, I know without putting a lot of thought in that you're this, right? You really want to have this Maclaurin series just in your noggin. Sorry, it's a minus, ready to go, right? You don't want to have to stop and think about this because that's just not the kind of thing you have time for on a long AP test, okay? Notice I'm only asked for the first 4 non-zero terms, not the general term, right? And then I'm in that same conundrum where what's going to happen is my f of x is going to be something that has to be distributed, and it's not going to be super fun, right? X minus the x cubed over, I might leave it as a 3 factorial for right now. We'll find out in a sec how ugly this gets, right? So dot, 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 dot. Okay, so let's start distributing. And I made a mistake in the last one in the sense that it's probably easier to start with the constant term first, because since it's the lower power, you're going to figure out more quickly how far you actually have to go in terms of getting the number of terms that you need. So when I distribute this guy, let's start with this guy first. We'll get a negative 4x, right? A plus 4x to the third over 6, which we'll deal with in a sec. And actually, let me give myself a little space. Looking ahead, I can see that what's going to happen is that when I distribute the x, I'm going to get the even powers, right? Because it'll be an x squared and x to the fourth. So I really only need to go up to x to the fourth, I'm pretty sure. And the reason I say that, again, is because, so I'm going to stop. I'm going to just try these 2 first. And the reason I'm going to do that is I'm going to say, wait a second, when I start distributing this guy, I'm going to get an x squared, right? Which is definitely not lining up with the other terms, right? An x squared. And then I'm going to get minus an x to the fourth over 6. Oh, hey, those are my terms. Because if I go any farther, if I'd gone any farther with this, I would have gotten a minus 4x to the 5th over 5 factorial. Well, look, I only had to give you the first 4 terms. That's too far. So anything after that is more than I need. Anything I do to multiply past that, if I take the x times the x to the 5th, that's an x to the 6th. That's still farther than I need. Everything else I do would be higher than an x to the 4th. So it turns out that the only terms I need are my f of x is equal to negative 4x plus an x squared plus, and you could leave it as 4/6, or you could make it a 2/3, it doesn't matter, minus 1/6 x to the 4th plus dot, 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 dot. And those are my first 4 terms. All right. So in this one, I'm asked, what is the sum of the given series? Right? So I'm asked, what does this series sum to? The trick here, right, is I need to look at this and say, hey, is this one of those Taylor-Maclaurin series that I've seen before, right? So here's what my brain says, right? My brain says, is it a Taylor-Maclaurin series? And then a sub-question in there, I make some notes. First note I make is, oh, they're all positive. So could it be e to the x? So I ask myself, okay, well, e to the x is a 1 plus an x squared over 2 plus an x cubed over, well, it's a 2, but it's a 2 factorial, if that helps, okay, etc. And then I look at this and I say, wait a second, this is a 1, right? This could be my x. This could be my x squared over 2 factorial, because 2 factorial is just 2, right? This guy could be my x cubed over 3 factorial, because 3 factorial is definitely 6, right? And so what I realized is, oh, hey, this is very much the series for e to the x, but where x is 5. So this is e to the x, right? So this thing, dot, 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 would equal e to the x. The difference here is that everything I'm looking at is a 5, not an x. So the answer is that this is e to the 5th. So what this question is asking you for pattern recognition. So my brain says, hey, you want to know what the sum's to? It's probably a Taylor and Maclaurin series. Let me see if this fits, if there's a number plugged in. So I want you to look at this one and think the same thing. What is the sum of this series? Okay. So a couple things I notice, right? The first thing I notice is it's got all odd powers. The second thing I notice is this 7 factorial. Right? Second thing I notice is, ooh, there's an odd factorial. So hopefully when you see this, your brain goes, oh, hey, I bet it's sine. So you know that hopefully sine is x minus x cubed over 3 factorial plus x to the 5th over 5 factorial minus x to the 7th over 7 factorial, right? Dot, 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 dot. And you look at this and say, oh, hey, that's this exact pattern except x is 2. So this thing is the sine of 2. All right, moving on. So sometimes you're not asked to find the entirety of a Taylor-Maclaurin series. You're just asked to find a specific term in the series. So in this case, you're just asked, what is the coefficient of the x to the 6th term? So remember that sine of x is x minus x cubed over 3 factorial plus x to the 5th over 5 factorial plus da 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 da. But notice that you're not doing sine of x here. You're doing the sine of 2x squared, meaning anywhere you see an x, you're plugging in a 2x squared. So sine of 2x squared is going to be, instead of an x, a 2x squared, minus, instead of an x, this will be a 2x squared to the 3rd over 3 factorial. Well, this is the term they're talking about because they want x to the 6th. So it's this term. You're asked, what's the coefficient? Well, that's going to be, so this thing's cubed, right? So that's going to be a negative 2 cubed is 8. X to the 6th over 6. So the answer is a negative 4/3, right? That's what the coefficient of the term is, okay? Same thing, I want you to try what's the coefficient of the x to the 3rd term in this series, right? So again, you want to immediately in your brain say, oh, I know e to the x is a 1 plus an x squared over 2 factorial plus an x cubed over 3 factorial plus an x to the 4th over 4 factorial. Dot, 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 right? Then you want to say, but it's not an x, it's a 3x, right? So e to the 3x would be a 1 plus a 3x plus a 3x quantity squared over 2 factorial plus a 3x quantity cubed over 3 factorial plus, and this is the one I'm going to end up wanting, a 3x to the 4th over 4 factorial plus dot, 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 dot. Now you might say, why is this the one I'm going to end up wanting? Well, the last step in this is divide everybody by x. So e to the 3x divided by x is going to be a 1 over x, a 3x over x, right? 1 over x, 3x over x, da 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 da. This is the one that's going to end up being cubic because this is going to be an 81 x to the 4th over 24, all divided by an x. Well, dividing by x is what's going to give me that cubic term. So I'm going to get 81 over 24 times an x to the 3rd. And you could leave your answer as 81 over 24. Like this would be a totally acceptable answer. Or you could simplify if you want. You could cancel a 3 if you wanted, and you'd get a 27 over 8. But again, that's kind of gutsy, right? Because so it might be smarter to leave your answer as an 81 over 24, but it would be fine to say 27 over 8. It's easy to do everything right and then pick the wrong fraction because you just simplify wrong. So, all right, now this one's tricky again. So what is the coefficient of the x to the 4th term for this series? Now the reason this is tricky is you're foiling two infinite series, right? So it's sine times sine. So what's happening is this is going to be x minus the x cubed over 3 factorial plus the x to the 5th over 5 factorial plus dot 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 times the exact same thing the second time. The trick here is that since I want x to the 4th, I only really care about terms that are x to the 3rd or lower because there's no chance, like both of these are too big to multiply to an x to the 4th. So as I multiply, right, I'm going to FOIL / distribute, right? It's not technically foiling, but My first term, right, would be x times x, so that's an x squared. So I'm gonna distribute this guy first, x times x, right, minus x times x cubed over 3 factorial. So that's an x to the fourth over 3 factorial, right? So that's this guy to this guy, this guy to this guy, right? And then there's no point in going any farther because I don't care about x to the sixth, right? I only care about x to the fourth. Then I take this guy and distribute, and I'm going to get this guy times this guy, so that's going to be a negative x to the fourth over 6 again, right? And then this guy times this guy is an x to the sixth, so it's too big. Like, I don't care, right? So I don't really care about that at all. And any other terms that I use, right, would be too big, right? So it turns out that all I care about are these two, right? Because I wanted the coefficient of the x to the fourth. Well, it's a negative 2/6 x to the fourth, or so your answer is either negative 1/3 or negative 2/6. You don't have to simplify, you just have to be able to get there. All right, same trick for P6. I want you to give this a try, right? And this should be our last example in this video. So again, this is a cosine times a cosine. So you're not actually able to find the entire series. You're just looking for the x to the fourth term, right? So you want to know that this is a 1 minus an x squared over 2 factorial plus, and then you really don't care that much because, well, I lied, you do. You care to the x to the fourth because the 1. Plus an x to the fourth over 4 factorial. After x to the fourth, you don't care, right? Because you need to multiply 2 to x to the fourth. So this is a 1 minus an x squared over 2 factorial plus an x to the fourth over 4 factorial plus da 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 da. Okay, so when you distribute, right, if you take this guy and distribute, you're just going to get, so if you distribute to him, that's not an x to the fourth. If you distribute to this guy, that's not an x to the fourth. If you distribute to this guy, that is an x to the fourth. So you're going to get an x to the fourth over 4 factorial, right? Because that's the only thing I care about is x to the fourth. I could have done that on the last slide too. If I distribute this guy times this is not an x to the fourth, but this guy times this guy is an x to the fourth. That's an x to the fourth. It'll be positive because they're both negative. Over, this is 2 times 2, right? 2 factorial is 2, so 2 times 2, which would be 4, right? And then when I distribute this guy, if I distribute this guy, I get an x to the fourth, so that's plus an x to the fourth over 4 factorial, right? But anything else I multiply by is too big, it's not an x to the fourth. So this is what I want, right? These are all my x to the fourth terms, right? And I need to put them together. So this is a 1/24th x to the fourth plus a, so 1/4 is the same as 6/24 x to the fourth plus another 1/24 x to the fourth. So I'm pretty sure I get 8/24 x to the fourth, or so you could either answer as 8/24, right, which is fine, or you could say 1/3. So again, those are kind of tricky versions of this, but notice the big thing was that at no point did I have to go back and look at these series. You have to have them memorized. Please memorize these series.